Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also, I'm going to discuss about a very important topic that every civil engineer should know, that is bulking of sand. What is bulking of sand and why it is important, and what is the measure and how to measure as per Indian standard, that I will discuss everything in details in today's video. So stay tuned until then to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject, that is bulking of sand. And first thing, we need to know what is bulking of sand. So according to the definition, that bulking of sand refers to the increase in volume of sand due to the presence of moisture. So whenever the sand particles take the moisture, its volume is increases. Why? When sand is moist, it forms a thin film of water around and sand particles, causing them to repel each other. So what is happening whenever the sand is taking the moisture? A thin layer of film is created around the sand particles, and every sand particle has the same particles, and there is a ripple effect. So whenever these two are coming together, it is repel each other. So whenever it is repel each other, the distance in between the two particles is become more, and in cumulative overall volume of the sand is increasing. So if the volume is suppose 20 cubic meter, it is increased maybe 22 cubic meters. So apparently we are getting more volume, but actually the sand is not that much. So this condition or the phenomenon is called the bulking up sand. So water the sand particles in them, causing them to repel each other, hence occupy more volume. So when the sand is occupying with the moistures, it apparently increase the volume. So but that much of volume of sand is not available. So this condition is called the bulking of sand. This bulking of sand is very much important where we are doing anything in the volume batching, whether it is a concrete, mortar, and anything and everything which is a volume batch. It is very much important because it is increasing the volume. If we are saying that we need 20 cubic meter of sand, but actually whenever it is showing, maybe it is showing 20 cubic meter, but actual whenever I'm measuring 20 cubic meter sand, due to this bulking of sand, maybe it is 18 cubic meters. So we are getting less amount sand. So that is affecting so much way in our construction. That is why we need to know why to know bulking of sand, or what is the effect of bulking sand. First is an accurate mix proportion. So if there is a bulking of sand, then what will happen? There will be accurate mix proportion. Why? Bulking increase the volume of sand due to moisture content, leading to incorrect volume in measurement in the accounted for. As already discussed, if this is a volume mix, what will happen? If I need 20 cubic meter of sand, I measured that one, but actually I will get 18 cubic meter or 17, whatever, as per the condition. This is other, the 2 cubic meter or 3 cubic meter will be the moisture. So we will get the less amount of sand. So result in less cement and aggregate in the mix, weaken the overall strength of concrete or mortar. So if it is an inaccurate mix proportion, we will not get the strength and the durability. Then again, it is a reduced strength. Why? Because inaccurate sand volume can result in lower cement content, and concrete or mortar may fail to achieve the desired compressive strength, compromising structural integrity. So it is affecting the strength also. Then poor workability. Again, the misjudged sand volume affects the water cement ratio. Again, we are calculating everything on a base of the X amount, say for 20 cubic meter, but actually we are getting 18 cubic meter. So these 2 cubic more these 2 cubic meter, this moisture is there, and also we are getting the less amount of sand. So the water cement ratio is become affected, and water cement is increase. And when the water cement ratio is increased, can lead to overly stiff or overly wet mixes, making placement and finishing more difficult. So it becomes poor workable. Then increased segregation and bleeding. So what is segregation and bleeding? Whenever the ingredients of concrete is separating from each other, that is called the separation of ingredients. And there are two types of separation. One is separation of coarse aggregate, that is called for the segregation, and another is separation of water or the cement paste, that is called the bleeding. So there are two types of separation: segregation and bleeding. So what is segregation and bleeding, and what is factor affecting, and what is the best practice to avoid segregation and bleeding? I have made a detailed video. Link is there or in the description. Please check. You will get full information. So the bulking of sand also has effect on increase segregation and bleeding. So if segregation and bleeding is happen, what will happen? We will not get the right kind of concrete or the mortar and everything. So there will be reduced strength, or will be non-homogeneous paste. So again, it will be a problem for the structural integrity. Then again, it is the inconsistent quality. What does this mean? That variation in sand moisture content cause fluctuation mix proportion. That means that every sand has not the same bulking of cement. So today I'm getting maybe 20%, tomorrow I'll get the 22%. So there is a fluctuation. And whenever this much of water present, the water cement ratio is also fluctuating, and so that there will be a problems in quality. So products produces inconsistent batches of concrete or mortar, leading to variability in strength and performance. So there will be a variability in strength and performance if the bulking of sand is not compared or is not measured and it is not corrected in the mix. Then cracking and shrinkage, that is also an effect. Improper sand content alters the mix drying and curing properties. And what is happening? That increase the risk of drying, shrinkage, and cracking, affecting the durability and appearance of the concrete surface. So again, it is a harmful effect for the concrete or the structure, so that there will be a crack, shrinkage case or whatever, and this crack will be a weak zone to penetrate moistures and other harmful chemicals like chloride, carbon dioxide, etc. Again, the corrosion can be happened. So this cracking and shrinkage is also has an effect of bulking, and bulking can influence this cracking and shrinkage. The next is increased permeability. So insufficient cement paste due to incorrect sand volume leads to more porous concrete, making it more susceptible to water ingress and related issues like corrosion of same reinforcement. So these are also, bulking of sand also has a detrimental effect in the permeability, and eventually it is affecting the durability of the structure. Then higher long-term maintenance cost. So it is, as we are not pouring the right kind balance of concrete or right proportion of the mix, then it will be the weaker concrete. And if this is weaker concrete, we need to do the long-term maintenance. And if we need to do the long-term maintenance, what will happen? Will increase the cost of the project. So cost of the maintenance, and also there is a chances of the structural instability. So these are the things that bulking of sand can has the detrimental effect on this. That is inaccurate mix proportion, reduced strength, poor workability, increased segregation and bleeding, inconsistent quality, cracking and shrinkage, increased permeability, and higher long-term maintenance cost. So that is why these are all the things is a negative impact on the project or the cost. So these we need to know what is the bulking of the sand and how we need to measure the bulking of sand, and accordingly we need to rectify or redefine our mix proportion. The next is relevant IS code is IS 382386 Part 3, reaffirmed in 2021. Next is how to measure. This is also measurement is showing in clause 4.32 and 4.33 in IS 2386. It has given detailed procedure how to measure the bulking of sand. It is very simple, yeah, that everyone knows that when we are doing in the laboratory, in the site lab, this is a very simple method that create a sample of moist sand to be tested. That take a sample and place the sand loosely in a 250 ml measuring cylinder up to 200 ml mark without compacting. Note that the initial level, let's call it V1. So we need to take the 250 ml cylinder and we need to pour the sand up to 200 ml. Now what we need to do? Fill the cylinder with water and stir the sand sample thoroughly to ensure all the voids are filled with water. Next, what we need to do? After the sand settles, note the final level of the sand. Let's call it V2. So First, we have taken the 200 ml sand in the cylinder, then pour the water, stir the water, and then settle the sand. Then again, we need to measure the water, the 2 V2. So what will be the bulking? That means V1 minus V2. So what is happening whenever we are pouring the moisture sand, that V1 is the volume of including the bulking. So this will be the more volume. And after stirring the water, whenever it is a saturated condition, then it will settle down, then the volume that will be V2, and it will be the only sand particles volume. So bulking will be V1 minus V2, or the initial volume minus the final volume by the divided by V2. Why V2? Because V2 is the actual volume of the sand, but V1 is the volume of sand plus the moisture. So that is why actual volume to be divided by V2 into 100. This gives the percentage increase in volume on the moist salt sand over its dry volume. So let's take an example. If volume is 240 mm V1 and V2 is 200, then 240 minus 200 divided by 200 equal to 20%. So bulking of sand will be 200%. So whenever you are getting the sand, please measure the bulking of the sand. Whenever if you are dealing with the volume mixing, whenever you're making mortar or concrete by volume mix, please measure the bulking of sand and correct your mix proportion accordingly. And if it's a very simple method, you can check in 4.3.2 or 4.3.3 in IS 2386 part 3, and it is described very simple method. So these are the bulking of sand you need to measure as per IS 2386. And bulking of different sand zone, the zone 1, zone 2, zone 3, zone 4, all we know there are different fold zone as per IS 383 or as per Indian standard. But what is the different sand zone? What is the different particle size distribution? I have made a detailed video. Please check, or in the description you will get full information. But whenever it is come to bulking of sand, zone 1 has least bulking, zone 2 moderate, zone 3 high, and zone 4 is highest. That is why our concrete is always, we are choosing zone 1 or zone 2. Zone 4 is always advisable not to use in the concrete, because it's a finer particle, and also the higher volume of bulking of sand, the moisture content is more. So these are the things about the bulking and sand. It's so easily you can measure, but it is important to measure whenever you are dealing with any kind of volume mixing with the sand. So I hope you enjoy this one, and if you enjoy this one, kindly subscribe my channel and hit the bell icon, so that whenever I upload a new video, you will get immediate notification. And I'm waiting for your valuable comment, so that from your valuable comment, everybody will be benefited. And if you want to know anything more about concrete, about construction, or the quality control, please let me know. I will come with more content like this. And thank you once again for watching me.